In this session, we will discuss self-ionization of water. We know water is a unique compound due to its ability to accept proton as well as donate proton under different environment. Water molecules are highly polar and the collision between water molecule is responsible for the transfer of proton from one water molecule to another water molecule. Now we will see how proton will transfer from one water molecule to another water molecule. We will write one water molecule. Here we have water molecule H2O. Oxygen of water molecule has two lone pair of electrons. And here we will make the second water molecule. Oxygen of water molecule has two lone pair of electrons. Now, during collision between water molecules, a proton is transferred from one water molecule to another water molecule. This proton is shifted from one water molecule to another water molecule. Now, after accepting proton from water molecule, the second water molecule, one water molecule changes to a positive charged ion that is known as H3O+. This ion is known as hydronium ion. While another water molecule after donating proton changes to a negative charged ion that is known as hydroxide ion. This ion is known as hydroxide ion. Students, this is the reaction in which two water molecules produces ions. That's why this reaction is known as self-ionization or auto-ionization of water. Since in this reaction, two water molecules produces positive charged ion as well as negative charged ion. That's why this reaction is known as self-ionization of water or auto-ionization of water. We can write this reaction in a simple way. That means simple ionization of water can be written like we have water molecule. We have two water molecules, students, and after shifting of proton from one water molecule to another water molecule, we get positive charged ion, that is hydronium ion, as well as negative charged ion, that is hydroxide ions. We can write this reaction in a simple way, that is a simple ionization of water. For example, if we have one water molecule ionizes H2O, right? Ionizes to give hydrogen ion, which is known as proton, as well as hydroxide ion. Hydrogen ion or proton is positive charged ion, while hydroxide ion is known as negative charged ion. I hope self-ionization of water or auto-ionization of water is clear to you. Now we will see what is the self-ionization constant of water or Kw. In order to understand ionization constant of water or Kw, once again we will write the ionization reactions of water. Auto-ionization reaction of water is H2O, water molecule ionizes to hydrogen ion as well as hydroxide ion. If we are asked to write the Kc for this reaction, Kc for this reaction is equal to product of the molar concentration of product to the product of the molar concentration of reactants. Students, here what are products? Hydrogen ion and hydroxide ions, they are products. So products should be written as numerator in the square bracket. Square bracket shows the molar concentration of product in moles per cubic decimeter. So we write molar concentration of hydrogen ion into molar concentration of hydroxide ion over what is the reactant here? Reactant is water molecule, so molar concentration of water. Now we know water is present in the form of solvent. It means water is present in very large excess and only very few molecules of water ionizes, since water is a weak electrolyte. only very few molecules of water ionizes. So the concentration of water is almost remain constant. So we can write as Kc into molar concentration of water is equal to molar concentration of hydrogen ion into molar concentration of hydroxide ions. Kc into molar concentration of water is equivalent to another constant. Kc, since Kc into molar concentration of water, it is equivalent to another constant that is known as Kw. Kw is the ionic product of water or ionization constant of water. What is Kw? It is ionic product of water or ionization constant of water. Now substituting the value of Kw, so equation would be Kw is equal to molar concentration of hydrogen ion into molar concentration of hydroxide ions. Molar concentration of hydrogen ion into molar concentration of hydroxide ions. And we know what is Kw. Kw is ionic product of water or ionization constant of water. Kw is ionic product of water, or it is ionization constant of water. Ionization constant of water. Water is a weak electrolyte. The self-ionization of water occurs to a very small extent. So experimentally determined concentration of hydrogen ion and hydroxide ions are, what are the experimentally determined concentration of hydrogen ion? The experimentally determined concentration of hydrogen ion is 1 into 10 raised to power minus 7 mole. Similarly, experimentally determined concentration of hydroxide ion is 1 into 10 raised to power minus 7 mole. Since we know Kw is equal to molar concentration of hydrogen ion into molar concentration of hydroxide ions, so we substitute the values of molar concentration of hydrogen ion and molar concentration of hydroxide ion in this equation. After substituting the values, the equation would become Kw is equal to 1 into 10 raised to power minus 7 into 1 into 10 raised to power minus 7 at 25 degrees Celsius. At 25 degrees Celsius. Since Kw, that is ionic product of water or ionization constant of water, is temperature dependent. So this is the value at 25 degrees centigrade. Or we can write as Kw is equal to Kw, that is ionization constant of water or ionic product of water. It would be 1 into 10 raised to power minus 14. 10 raised to power minus 14 at 25 degrees Celsius. So it means we can say the molar concentration of hydrogen ion and molar concentration of hydroxide ions. Molar concentration of hydrogen ion is equal to the molar concentration of hydroxide ion at 25 degrees centigrade. I hope the topic of self-ionization of water and ionic product of water is clear to you.